All right, so let's take a look at the Geometry Chapter 5 review. Number 9 was a proof, and you are given AB is congruent to CD, AG is congruent to BE, and AG is parallel to BE. We need to prove that GC is parallel to ED. So let's start with the first given. Line AB is congruent to CD. So let me see if I can draw a shape here. There we go. You said AB is congruent to CD. Okay, and that's given. So the next piece of information we can figure out, BC is congruent to BC. That's going to be the reflexive property, right? So BC is equal to BC based on the reflexive. So now we have AB and we have BC. So think about this. AB plus BC will give us AC, right? And the same thing will hold true if BC plus CD will give me BD, right? That's based on the addition property. So we can go ahead and say AC is congruent to BC. So let me use a different color. So AC is congruent to BD. That's going to be on the addition property, all right? Now, we also have AG is congruent to BE, so let me choose a different color. AG is congruent to BE, and that was given. We also have AG is parallel to BE, and that's also given. So based on those pieces of information, we can go ahead and say that the measure of angle A, or you could say GAC, right? We'll just say the measure of angle A is going to be congruent to the measure of EBD, or just you could say B. And that's based on the fact that if you have two parallel lines, their corresponding angles are also congruent. So we have a side, we have an angle, and a side. We have a side, an angle, and a side. So we can go ahead and say triangle AGC is congruent to triangle BED, and that's based on side, angle, side. So remember, if the angle is included, right, it's in the middle of one side and the other side, it's side, angle, side theorem. So if these two triangles are now congruent, let me see if I can change the colors really quick. So I have this triangle, and I have this triangle. If they're both congruent, we could state that angle GCA, GCA, and we could say, oops, ED, we could say EDB are congruent based on corresponding parts of congruent triangles are also congruent, okay? And now we can state that line GC, see if we can change colors, line GC is parallel to line ED, because if their corresponding angles are congruent, then that deems, or that proves, that our lines are now parallel. All right, and it's helpful to draw a picture as well as use different colored pencils or highlighters, whatever helps. Let's look at number 10. We have a parallelogram, right? JHP is congruent to the measure of angle MKO. Okay, and then we have to conclude that line MP is congruent to JO. So the first piece of information that we have is that HJKM is a parallelogram, and that's given. Okay, we could then go ahead and say that JHP, so angle JHP, is congruent to MKO. All right. Actually, let me get rid of the lines. Let me just say, there we go. Because that's also given. All right, so if we know this is a parallelogram and we know that these two angles are congruent, that's based on the given information, we can now say that the measure of angle, let's see. Oh no, we could say that HJ is congruent to MK based on, right, the opposite sides of parallelograms are congruent. We could also say that HJ and MK are parallel, and that's also because opposite sides of parallelograms are parallel. Okay, we can now say that the measure of angle J or HJP is congruent to KMO. And remember your Z's, or remember the transversal of two parallel lines. Parallel lines means that their ultimate interior angles are then congruent. Okay, so remember, think of the parallel lines and the transversal, or think of your Z's. Now we have a side and we have two angles, right? And let's see. All right, so because we have, all right, two angles and a side, we can say angle side angle is going to be the theorem of proving that triangle HJP, see if I can, HJP, all right, is going to be congruent to KMO, right, to triangle KMO. And that's going to be based on the angle side angle. Next, we could say JP is congruent to MO. Okay, and that's going to be corresponding parts of congruent triangles, meaning that their other, right, their parts are also congruent, right? So this line we can say is now congruent. JP is congruent to MO because of the corresponding parts. We could also say OP is congruent to OP. That's reflexive. Okay, so now remember, we want to prove that MP is congruent to JO. So MP and JO. So now we have two of those segments. We could say, based on the addition property, that MP is congruent to JO. All right, again, it helps to draw in these parts with a different color. All right. For number 11, it's actually not proving anything. It's just stating or proving actually that ABCD is an isosceles trapezoid. Here's a picture from the textbook. You're going to have to use the slope formula to figure out the slope of BC, AD, and BC. And that will determine if it's an isosceles trapezoid or not. And same thing is going to happen in number 22. They want to know what kind of figure this is. It's eventually going to be a square based on the information. Find the slope of AC, BD, AB, and CD. Okay, you're going to notice AC is -2, BD is -2, AB is 1/2, and CD is 1/2. Okay, and based on that information, ABCD is a rectangle, and then eventually the diagonals are going to be perpendicular, so ABCD is a square. Okay, same thing with number 30, right? Because this is, I believe, let's see. Oh, we don't have enough information to tell what the figure is yet, but it can either be KE equals ET or ET equals TI. So I'm guessing this is going to be a kite, so we don't know which ones are equal to each other. So set it up as a formula. Y squared is equal to 5y plus 6, or y squared is equal to 2y plus 3. So again, you're either going to have y squared is either going to be equal to this, or y squared is going to be equal to this side. Okay, so those are your two possibilities. You want to set these up as equations. You want to use the quadratic formula. All right, so when you plug in your values, the A, B, and C, to get your quadratic formula, y can either give you 6 or -1. okay, 3 or -1. All right, so depending on your perimeter here, I think, actually no, if you plug in, let's see, p is equal to 30 plus 6. Oh yeah, if you plug in 6 for 6 for y and you determine the perimeter, right, you'll either get 102, you'll get 60, or you will eventually get 4. All right, so the answers are all there. If you have any other questions, please let me know.